Right now, somewhere off the coast of Greenland, a single drop of water is freezing into ice. And when that ice forms, it leaves something behind. Salt. Cold, heavy, salty water sinking down into the dark. Away from the sun, away from the wind, away from everything you would call ocean. That drop of water is about to begin a journey that will take 1,000 years to finish. It will travel farther than any human being who has ever lived. It will outlast empires. It will outlast languages. It will be moving silently in the freezing dark long after every person watching this video is gone. And when it finally returns to the surface, it will rise into a world none of us would recognize. This is the story of that one drop. Stay with me, because by the end of this, you will never look at the ocean the same way again. We have to start at the very beginning in the seas near Greenland and Norway, the coldest, harshest stretch of ocean on the planet. The water here is already cold, but something else is happening to it. As ice forms on the surface, it pushes the salt out of itself. The way a sponge pushes out water when you squeeze it. That salt doesn't disappear. It goes into the water around the ice, making it saltier. And saltier water is heavier water. Combine that with the cold, and you get something remarkable. You get water so dense, so heavy, that it can no longer stay on the surface. It begins to sink, not gently. It plunges thousands of meters straight down, like a stone falling through the sky. Except this stone is an entire mass of ocean sinking toward the sea floor in the darkness near Greenland. I should say up front, this isn't a process that started recently, and it isn't going to stop anytime soon either. Scientists have traced this same sinking, this same engine, back tens of millions of years, long before there were any humans around to notice it. It was running while dinosaurs were nothing but distant ancestors of birds. It was running through ice ages and warm periods alike. What we're doing today is picking one single drop, starting its journey at this exact moment, just so we have something to follow. The machine itself never stopped. It's been running this whole time, and it will keep running long after we're done talking about it. This is the moment our one drop is born into its personal journey. Scientists call this the North Atlantic deep water, one of the most powerful forces on Earth that almost nobody has ever heard of. Picture the volume for a second. Every single second, the amount of water sinking in this one region is roughly 15 times more than every river on the entire planet combined, pouring into the sea at once. Every river, the Amazon, the Nile, the Mississippi, the Yangtze, all of them together multiplied by 15, sinking quietly into the North Atlantic. And our one drop is just a single, microscopic part of that unimaginable mass beginning to fall. If you could shrink yourself down and ride inside that drop, here is what the next moments would feel like. The light disappears almost immediately. Within a few hundred meters, the blue of the surface turns to a deep, bruised indigo. And within 1,000 meters, there is no light at all. None. Not starlight, not moonlight, nothing. You are now in a part of the planet that has been in permanent, total darkness for longer than continents have held their current shape. The pressure builds around you. The temperature drops to just above freezing. And the silence is absolute, except for the slow grinding pressure of water moving water. The way a glacier moves rock, except this glacier is made of liquid and it never, ever stops. This sinking water doesn't just disappear into a void, it has a job. As it plunges and settles near the ocean floor, it becomes part of a current, a slow river within the ocean itself, and it begins to move. Not east, not randomly, but south, hugging the floor of the Atlantic. sliding beneath the warmer water above it, like a blanket being pulled underneath another blanket. This deep, cold river will carry our drop on a path so long that if you tried to walk it, it would take you longer than recorded human history has existed. And it is moving right now as you watch this, completely indifferent to anything happening on the surface above it. Here's where it gets almost impossible to wrap your head around. The water at the surface, where you might go swimming, where storms form, where ships sail, that water is being pushed and pulled by wind, and it moves fast, sometimes 10 or 20 kilometers in a single day. But the water our drop has now become a part of this deep sinking southbound current moves at roughly 1 centimeter per second. That is slower than a clock's second hand sweeping across its face. At that speed, in 1 full day, our drop has traveled less than the length of a football field, and it has thousands of kilometers left to go. So let's mark the calendar just to get a feel for the scale. Our drop begins its slow crawl south along the floor of the Atlantic Ocean today in total darkness. If we let 1,000 years pass on the surface above it while it makes this single journey, we are talking about a stretch of time that comfortably contains the rise and fall of entire dynasties, the invention of the printing press, the discovery of continents, and the birth of every country currently sitting on a map. And our drop won't even notice any of it happening. It will simply keep sinking, then crawling, then rising on a clock that owes nothing to human history at all. If this fascinates you the way it fascinates me, do me a favor and hit that subscribe button. Because what happens to this drop over the next stretch of its journey is going to completely change how you think about time itself, and I don't want you to miss it. As our drop continues its slow crawl south along the seafloor, let's actually try to picture the geography it's moving through, because it is not just an empty void down there. Somewhere between the coast of West Africa and the eastern edge of South America, the seafloor itself rises and falls in ridges and valleys carved out by forces deep inside the earth. Mountain ranges that in some places are taller than anything sitting on dry land, yet almost nobody has ever heard their names. Our drop slides past these silently, brushing along terrain that has never once seen daylight, on a stretch of the planet that we've mapped in outline using sonar and satellites, but have barely explored up close at all. Let's use a different kind of marker now, something a little more visceral than dates on a calendar. Every single language currently spoken on Earth, every one of the roughly 7,000 languages people use today, to argue, to fall in love, to tell stories to their children. Every single one of them is younger than the journey our drop is currently making. Entire languages have been born, spread across continents, and died out completely. All while this one drop was still somewhere in the middle of the Atlantic, crawling south through total darkness at the speed of a second hand on a clock. This is the part that I think about more than almost anything else in science. Human history, every war, every empire, every invention, every single thing you have ever learned about in a history class, happens on a time scale so short that the ocean itself barely notices it passing. We measure history in centuries and call that ancient. The ocean measures one complete breath of its global circulation in 1,000 years, and that's considered fast, geologically speaking. Our entire concept of long ago wouldn't even register as a meaningful unit of time to the current carrying our drop along right now. Eventually, our drop reaches a region of the ocean that almost no one thinks about. But that controls more of the planet's climate than nearly anything else on Earth. It reaches the Southern Ocean, the frigid, storm-battered ring of water that wraps entirely around Antarctica. Unbroken by any continent, the only place on the planet where ocean water can flow completely around the globe without ever touching land. This is where things get genuinely wild, because here, near Antarctica, A version of the exact same process that started our drop's journey happens again, but even more violently. The wind howls almost constantly around Antarctica, some of the strongest and most consistent winds anywhere on Earth. And as sea ice forms along the frozen coast, it pushes out salt the same way it did back near Greenland. Except here, the cold is even more extreme, and the water that results is some of the densest, heaviest water found anywhere in all the world's oceans. This water is called Antarctic bottom water, and it sinks even deeper than where our drop originally plunged near Greenland, all the way to the absolute floor of the ocean basin, the deepest, coldest, most pressurized water that exists anywhere on this planet. Our drop, arriving from its long crawl down the Atlantic, now gets caught up in this powerful current circling Antarctica. The Antarctic Circumpolar Current, which moves more water than any other current on the entire planet. More than the Gulf Stream, more than every river combined, many times over. It sweeps our drop eastward around the bottom of the world. And here, finally, after this unimaginable stretch of darkness, something begins to change. If you're still with me right now, I want you to imagine what it must mean to be moving for hundreds of years before you even reach the halfway point of your own journey. That's roughly where our drop is, swept up in the circumpolar current, somewhere south of Africa or perhaps south of Australia, about to begin the long, slow climb back toward the light. But before we get there, drop a comment below telling me where you think this drop is going to surface. Because I promise you, the answer is not what most people expect. As the Antarctic Circumpolar Current carries our drop eastward around the bottom of the world, branches begin to split away from the main flow. Like tributaries breaking off from a great underground river, except this river is the entire Southern Ocean, and these tributaries stretch thousands of kilometers wide. Some of this water peels northward into the Indian Ocean, some peels into the Pacific. Our drop, after its long stretch in darkness, is finally caught in one of these northward branches, and almost imperceptibly, for the first time since it sank near Greenland, it begins to rise. This rising is called upwelling. And it might be the single most underrated process on the entire planet, because almost nothing about life on Earth would work without it. As our drop slowly ascends, it begins to warm, not because it's near the equator yet, but simply because it's leaving the crushing cold of the deepest ocean and moving into slightly warmer layers above. And as it warms, it becomes less dense, and as it becomes less dense, it rises faster, pulled upward in a slow, steady climb that will take decades, maybe longer, before it finally reaches the surface and feels something it has not felt in 1,000 years: sunlight. When our drop finally breaches the surface, somewhere likely in the tropical Indian Ocean or the warm waters near Indonesia, let's pause and actually sit with how much can change in 1,000 years on the surface, even though the ocean barely blinked. Entire civilizations rise from nothing and vanish completely. Entire technologies get invented, perfected, and then made obsolete by something nobody could have predicted. Entire coastlines get redrawn by cities that didn't exist when our drop first sank. None of that mattered to the water. It was simply doing what water does. Sinking, crawling, circling, rising on a loop that doesn't check the calendar before it moves. And here's the part that should genuinely stop you in your tracks for a second. This isn't a one-time event we happen to catch in the middle. This is happening continuously, right now, in this exact moment, all over the planet. There are drops of water finishing journeys that began long before any current nation on Earth had drawn its borders. There are drops just beginning their descent near Greenland this very second. That won't surface again until long after everyone reading these words has been gone for generations. The ocean isn't just big, It's running on a timescale that makes the entire span of recorded human civilization feel like a single afternoon. And it was doing this long before we showed up to watch. Now that our drop has surfaced, warmed by the tropical sun, it doesn't just sit still. It gets caught up in surface currents drawn by the wind, drawn by the rotation of the Earth itself, and it begins a much faster journey back toward the North Atlantic, the place where this leg of the story began. This part of the trip moves quickly compared to everything before it, sometimes covering in a single year what took a century in the deep, dark crawl along the ocean floor. It moves through the Indian Ocean, possibly slipping around the southern tip of Africa, rejoining the warm surface flow that eventually feeds into something you may have actually heard of, the Gulf Stream, the same current that keeps places like the United Kingdom and parts of Europe far warmer than their latitude should ever allow. And then, after this entire staggering loop, 1,000 years of darkness, a slow crawl past mountain ranges nobody has named, a violent rebirth near Antarctica, a rise into sunlight in a world it never could have predicted. Our drop arrives back near Greenland, back into the cold. And the cycle begins again. It freezes, it pushes out its salt, it sinks once more into the dark. And a brand new 1,000-year journey begins, indifferent to whatever happens to be unfolding on the surface of the planet at that exact moment. This is what scientists call the Global Ocean Conveyor Belt. And once you understand it this way, through the eyes of a single drop, it stops being some abstract diagram in a textbook and starts feeling like what it actually is. One of the largest, slowest, most relentless machines on the entire planet, built out of nothing more than temperature and salt, running continuously for tens of millions of years, long before we existed, and almost certainly long after we're gone too. There's something I find strangely grounding about all of this, and I want to leave you with it. We spend our lives convinced that our time scale, the deadlines, the relationships, the news cycle is the only time scale that matters. But right now, while you watch this, somewhere beneath the surface of the Atlantic, a drop of water that sank centuries ago is still crawling through total darkness, completely unaware that anything we consider important has ever happened at all. And somewhere off the coast of Greenland right now, a brand new drop is just beginning its descent, on a journey that won't finish until long after this video, this channel, and quite a lot of human history has played out. If this kind of deep dive into the hidden machinery of our planet is something you want more of, subscribe. Because there are stranger and older processes happening beneath our feet and beneath the waves than most people ever stop to consider. And I plan on covering them. Let me know in the comments which part of this journey surprised you the most, because I genuinely want to know. Thank you for watching, and I'll see you in the next one.